Okay, class, today we're going to be doing the law of sines ambiguous case, and it's when we're given side-side angle. So specifically, we'll be given some sort of triangle, and we'll be given some sort of angle, its opposite side, and some other side that is adjacent to it. So it's angle, side, side. So it's two sides and then an angle all together, making the side, side, side. And the reason it is ambiguous case is because sometimes you can draw it like this, and sometimes given your information, your triangle that you can draw would be given like this with your A, and your B. And we don't know if this side A opposite the given angle should be like this, making an obtuse angle, or it should be flipped in that way, so that this is your A with an acute angle. So we're going to explore the different cases. So here's how we're going to determine if there's 0, 1, or 2 triangles exist with the SSA case. So there's no triangles going to exist if A is acute. So if your given angle is here and it's acute, and you have your height of your triangle, which we're always going to drop down a perpendicular, and we're given this opposite side A. So if your height is bigger than your opposite side of the given angle, so if H is bigger than A, then no triangle is going to exist, because you have this sort of right triangle right here made with the height, and this is the hypotenuse of this little right triangle here, and this hypotenuse has to be longer than the height. So if A is bigger than H, then no triangle is going to occur. And that's when A is acute. So if A is obtuse, so you have your obtuse given angle here, its opposite side, which is this one, and it's short, and it's shorter than this given side. So if this is, say, 10 inches long and this is 7 inches long, see, it doesn't complete the triangle. So no triangle would exist in that case. Two triangles are going to exist in the case when A is acute. So your given angle is over here. And when we draw our triangles, I want you to always draw your given angle over here, even if it's not called A. Just put your given triangle there, or your given angle here. And then its opposite side here is what we call A. So we have this big triangle here. And then the other side is B. So no matter what the other side is given for the SSA case, we're going to place it over here. And we're between the two given sides in the SSA case is where we're going to drop our perpendicular down for our height. So we have two triangles. I'll highlight the first one. So one possible triangle occurs would be this big triangle right here, as I've labeled it. And that occurs when your height is smaller than your A, and that's smaller than your B. Specifically, your height is less than this side, that's opposite this one, your given angle, and that's opposite than the other side that you're given. So if that's the case, then two triangles occur. One triangle that can be drawn is this one that I highlighted in yellow, and then the second triangle I'll highlight as well. It's when you, instead of drawing your A here, you draw your A here, and you get this, which I'm highlighting here in purple. This triangle is triangle number 2. So I could have drawn this big triangle, or I could have drawn this one that I shaded purple. And that what makes it the ambiguous case. So when you have an acute angle and your height is less than the opposite side, which is smaller than the other side, H is less than A, which is less than B, then two triangles are going to exist. And those are your two triangles, this big one here, and then this little one here. You do see this extra isosceles triangle in there, and we'll get to that in a bit. So if it's not the no triangle case, and if it's not the two triangles case, then one triangle is going to exist, and it's just going to be like the law of sines that we did originally. So what we're going to do here is we're going to determine the number of triangles for the following cases, given these angles. So you have your A, and your B. So this is going to be the SSA case. So in this case, I have an obtuse angle A, its opposite side A, which is 10, and its other side B, which is 3. So we see that we have A is obtuse, and we have that its opposite side A is bigger than its B. So we can look in the obtuse angle section what the case may be. So as we can see on the previous slide, no triangle exists if A is obtuse and A is less than B. And that's not our case for this example. So it's not the no triangle exists. So then we see, is it two triangles exist? Is A acute? Nope. So it's not the two triangle exists. The two triangle only exists if A is acute. So if it's not the no triangle, it's not the two triangle, then therefore one triangle must exist. Okay, so there we have it. One triangle exists. So now let's look at the second one. Here we have an acute triangle, so it really could be any. So I'm going to draw my triangle. Whenever I draw my triangle, I'm always going to draw it in this general shape. I'm going to put the given angle over in this location, no matter what it's called. Its opposite side will always be given in the SSA case, and I'm going to label it opposite. And then the other side, no matter what it's called, I'm always going to label it here. A is 15. And I'm going to do that because my height will always be this one that comes down to the ground. So this is my height. Okay, so I have my acute angle, so I'm going to have to determine the number of triangles. And to do that, I have to find the height of the triangle and compare it to this side and then this side. Now remember, two triangles exist if H is the smallest, and then this one over in this location is the medium sized, and then this one over here in this location is the largest side. So let's go ahead and find the height. So I have this right triangle here that involves the height, and since it's a right triangle, I can use SOHCAHTOA, and I have an angle, its opposite, and its hypotenuse. So I know that the sine of 62 degrees is H over 15. So I can solve for my height of my triangle by multiplying 15 to the other side, and H is 15 sine of 62 degrees, which is 13.24 for the height. So that tells me that this is 13.24. So now let's look at this triangle, which I'm going to outline in green here. This side is 13.24, and if you look at just this right angle, this must be the hypotenuse of this green triangle here. The hypotenuse is 7 and the height is 13.24, which doesn't make sense since the hypotenuse is supposed to be the longest side. So this tells me that no triangle is going to exist. You simply cannot draw a triangle with the height being 13.24 and the hypotenuse being shorter of 7. And that matches up with what we have here. If your given angle is acute up here and you have your height and its opposite side, if the height is bigger than the opposite side A, the height is bigger, then no triangle exists. Okay, so let's solve this triangle, and we're given a side-side angle. So whenever we're given the side-side angle, we need to determine the number of possible triangles that's going to exist. So we're going to draw our triangle generically, like this big triangle here, and then I'll explain this inner triangle afterwards. So whatever our angle is given, no matter what it's called, we're going to put our given angle over here. In this case, it's A. Its opposite side is always going to go over here, and the opposite side will always be given. The other one that's given will always go here, adjacent to the given angle. So in this case, B is 12. Oops, excuse me. In order to determine the number of possible triangles, we're going to have to see what H is, and we're going to compare the height to the other two sides when our A is acute. So in order to find the height, what we're going to do is we're going to look at the right triangle given. And the right triangle given is this one. And when we have a right triangle, then we can use SOHCAHTOA. So we're given sine is opposite over the hypotenuse. So I know that the sine of 42 degrees is H over 12, or my H is 12 sine of 42 degrees. And when I put that into the calculator in degree mode, I get 8.03 for my height. Okay. Looking back here, when H is acute, we need to look at the height if it's bigger than the opposite side, or if the height is less than its opposite side, which is less than the one that is adjacent to it. Determine if it's none or 2, and then if not, it'll be 1. So looking back here, our height is about 8, and that's the smallest side length. This one is the next biggest, and then that one is the next biggest. So my height is less than the opposite side, which in this case is called A, which is less than the adjacent side, which is called B, because my 8 is less than my 9, which is less than 12. So when that happens, we know that two triangles exist. So when you have your two triangles, we're going to draw them as follows. the first triangle is going to be just like we've been drawing them, like this. We're going to put our assigned given angle here that's acute, its opposite side, and then the one over there. But two triangles exist. I don't know that this is how I should have drawn my triangle. What I do is I take this side, which is opposite the given angle, and I'm going to swing it to the other side of your height, so that this instead is your A. And you see this orange triangle here is an isosceles triangle because A is congruent to A. I'm just swinging it over here. How did I know to draw it out there? I don't. I really could have drawn it in there. And this gray triangle is what we call triangle 2. So we've labeled our A and our B. So if this is our B, the angle opposite it would be angle B. So up here would be the left angle C, and then this big side here is side C. When we solve the triangle, these are the responses that's going to come out first from our calculator, and with those we'll be able to determine triangle number 2. So we have our A and our A. Opposite A is our B, so our other angle here, and so to label them, we're going to label them B2, C2, and this one side C2. So often label these C1 and B1. So this is triangle 1 and triangle 2. And it really doesn't matter which is triangle 1 and which is triangle 2. It's just all of this together needs to be for one triangle. All of that together needs to be for the other triangle. Okay, so let's go ahead and solve. Okay, so we're just going to go about solving this using the law of sines, and I'm going to solve for angle B1 first. So let's go ahead and set up our ratio to solve for B. Okay, so I plugged everything in. I multiplied 12 to the other side to get the sine of B1. I wanted to isolate B1, so I did sine inverse of both sides, and I just left everything in the calculator to find B1, and then I put it into DMS form, and I got that it was about 63 degrees. So with those two angles, then I'm able to find this one because the sum of the three angles is 180. So we can do that next. So if this is 42, this is 63 degrees, 8 minutes, 52 seconds, and then we don't know this one, but the three sum to be 180 degrees, then I can just subtract to get that angle C is 74 degrees, 5 minutes, 51 minutes, sorry, and 8 seconds. So now I've solved all the triangles, or sorry, all the angles, so now I can find my remaining side C1, and I'm going to go ahead and set up the trig ratio with A and C to solve for my side C. So for this one, since I wanted to find a side, I flipped the ratio so the sides were on top. I chose to compare A and C because C is what I wanted to find, and A just had a nicer number 42 versus 63 degrees, 8 minutes and 52 seconds. So A was easier to work with than B. So I set up my trig ratio. I'm just going to multiply sine of 74 degrees and some stuff to the other side to find my C. So after it's multiplied to the other side, I end up with this, plug it into the calculator, and I get 12.98. So that is the solving triangle 1. So now we can go ahead and solve triangle 2. Okay, so this is the setup that we had for the first triangle. And remember, to solve the second triangle, we're going to take our opposite side, that's opposite the given angle, and swing it to the other side of the height to form this isosceles triangle. Okay, so if this one here is our B1, this one here is also our B1, which is 63 degrees. Now our second triangle that we want to solve is this little one here. Highlighted in yellow, we have the second triangle. So we have our angle B1 that we found, which was over here, and because this white triangle is isosceles, since I just moved that side over there, this is my A, which was given as 9, and I want to solve this little yellow triangle here. I'm going to use the fact that this is isosceles, so those two are congruent, and then these two are supplementary. So B1 and B2 will always be supplementary. So if I know that this is B1, I can go ahead and find B2 now. So they're supplementary, so they sum to 180, so we can subtract B1 from 180 to get B2. So now I have B2 and I have A, and I can find C2 using the fact that they sum to be 180 again. So we have that C2 is 21 degrees, 8 minutes, 52 seconds, since they sum to be 180 in the triangle. So the last thing to do is to find little c, so we can set that up using law of sines. So again, I want to find a side length, so I put the side on top. I plugged in my knowns, comparing it with A. I'm going to multiply sine to the other side to get my C2 isolated. So after I multiplied the sine over and multiplied everything too, I got C2 is 4.85, and we solved both triangles. Thank you.